So we're looking at polynomials more in depth now. We've been working with polynomials all along. When we have a line, when we're graphing a line, it's a polynomial. When we're graphing a parabola, it's a polynomial. They just happen to be very common polynomials, and so we spend a lot of time on them because you have to know how to do those really, really well. And once we get those basics, then we can extend that understanding to some higher degree polynomials. So we're looking at polynomials now with a power of 3 or a power of 4 and sometimes higher. Polynomials, when you graph them, if you have a graphing calculator, then you can graph them really easily. I like to call them the roller coasters. They're nice, smooth curves. There's no sharp points. There's no weird things happening. But when you think about a line, it's nice and smooth. When you think about a parabola, it's got a nice, smooth curve. And as you get higher powers, then you have more curves and more valleys and peaks and stuff like that. So we're working with some naming today, some vocabulary, and then operations you already know how to do. We're just going to make sure you can do them again. You should have no trouble finishing today's worksheet. But in your notes, we want to definitely have these tables in there that are the terms. So example 1, we want to name each polynomial by the degree and the number of terms. Go ahead and double up. I don't know whose phone was in 35, but you're in the wrong spot. There you go. Sucks. All right. So example A, B, and C here, or problem A, B, and C, are examples of polynomials that are kind of crazy. The degree, you can see here, the degree happens to be the highest power of x. And that highest power tells us a lot of information, which we'll talk more about later on. But these are all the different names. We have if it has a power of 0, we have that'd be a constant function. If it's x to the first power, we would call that linear. X squared is quadratic. That's our quadratic, our parabola. X cubed is called cubic. X to the fourth is called quartic. And anything 5th degree and higher, you can see the ellipses here, the dot, dot, dot ellipses. Anything 5th degree and higher, we would just call it a 5th degree or 6th degree or 7th degree polynomial. We don't have special names for those. Those are more rare for us. Classifying by number of terms. You've heard me say all of these words before. If it has 1 term, it'd be a monomial. 2 terms, binomial. 3 terms, trinomial. And then again, you can see the ellipses here. Anything 4 or more terms, we would just say 4 term, 5 term, 6 term. No special names for those. Oh, and there's a seat up there if you want. Yeah. See it there. Alright, so people are still ready. I'll give you a few more seconds. I can flip back to this later if we need to. So A, B, and C are examples of polynomials, and when we look at the terms, here I see a few terms here. When I look at the x's, we have x squared, x to the fourth. This is actually x to the 0, negative 7x to the 0. What happens if you have a number like 3 to the 0, any number to a power of 0? What is that equal to? Three to a, oops. Oh, geez. There we go. 3 to a power of 0 is something you could do on your calculator if you ever couldn't remember. Any number to a power of 0 is 1. Always. All right. So if you see x to a power of 0, what's x to a power of 0? 1. Doesn't matter what it is. 273 to a power of 0 is 1. Okay. And so here, whenever you don't see an x on there, it's because it's x to the 0. X to the 0 would really just be 1. Well, we wouldn't write that because y multiplied by 1. That's just unnecessary. But no, it's there. That's important to know. And when you look at that, what is the highest power? All right. What's the highest power of x? Wasn't a trick question. What's the highest power? 4. Yeah, they're right there. The highest power is 4. That is the degree. That is the most important. And so we say this is a 4th degree. And then how many terms do you see? 3 terms. Yeah, 1, 2, 3. 3 terms. And so we want to actually classify that with special names. So what do we call a 4th degree? Quartic. Quartic, yeah. Quartic and 3-term trinomial. Quartic trinomial. You can see I put lots of different coefficients on here. We've got a -3, we've got a 1/2. Coefficients can be anything, decimals, even irrational numbers like pi and radical 2. It doesn't matter what the coefficients are. If it's a real number, then it's fine. As long as the powers are nice, normal, whole numbers, 0, 1, 2, 3, 4, 5, that sort of thing. Here, what's the highest power? 2. So this is a 2nd degree. And how many terms? 2 terms. So how would we classify this? Quadratic binomial. Very good. Quadratic binomial. And then letter C, radical 2 times x cubed. What degree is it? Degree 3. And how many terms? 1 term. And so we would call it what? Cubic. And 1 term is monomial. Cubic monomial. So So this is like half your worksheet, pretty easy to do. Just looking for the highest power and counting the number of terms. And again, if you have a graphing calculator, you could graph these and see that this is just a parabola. Cubic, this one looks something like that. Fourth degree looks kind of like that. I don't know what's in the middle, but arms up like a parabola. You're going to be working with some graphs later in the week. All right. Any questions on that one? All right. Example 2, simplify each expression. Simplify each expression. Simplify each expression. So by simplify each expression, you are looking at whether or not we are adding, subtracting, multiply, or dividing polynomials. Oh, we're not going to divide. Add, subtract, or multiply. We'll be dividing later. And so with letter A here, we have x to the fourth plus 2x cubed plus 8. And then a symbol. What operation are we doing for the letter A? Add, subtract, or multiply? Subtract. Please pay attention. You've done this before. We are subtracting. Please pay attention to the sign in the middle. I saw again on the most recent test you guys took. Again, all we were supposed to do was combine like terms, and I saw people get crazy and multiply. All right, but all we're doing is adding or subtracting. What should we do for the subtraction? Distribute the negative. You can think about it like a -1. So we need to distribute the negative. Once we do that, we can drop the parentheses. You no longer need them. X to the fourth plus 2x cubed plus 8. And I'm going to do -1 times 2x to the fourth is -2x to the fourth. And -1 times -9 is +9. So all that does is change the signs. And then we are going to combine like terms. Don't get crazy. What does it mean to be like terms? Exactly the same. What makes them exactly the same? Exact same exponents. They have to have the exact same exponents, all right? So be careful. You do have a few weird problems where you get some crazy powers on there. So we're going to combine 1x to the fourth and -2x to the fourth. So it's 1x to the fourth and a -2x to the fourth. -1x to the fourth. You'll notice, did the power change? No, we do not get x to the 8th. All right, the only number that changes is the coefficient. All right, powers stay the same, change the number. Does 2x cubed have any friends? No, so plus 2x cubed. And then +8 and +9 is +17. This is what we might call general form or standard form, where we have the highest power in front. The highest power is first, and that whole first term, that term with the highest power, is a really important term. It tells us all kinds of information about that polynomial. And from there, we just count down our powers of x from highest to lowest, typically. All right, letter B, what operation are we doing here? Or what do we need to do on letter B? Right, yeah, this is a power of 2, means repeat. repeat everything in parentheses 2 times. So that's what I always advise. Write it out 2 times. And now what operation is this? Distributive or multiplication? Yeah, distribute or multiply. So we are multiplying these, which we can do by distributing. So I'm going to distribute 5a times 5a and get 5a squared. When we multiply, you'll notice our powers are going to change. All right? So pay attention. When we're just adding or subtracting, the powers stay the same. But when we multiply, a to the first times a to the first becomes a to the second. Then I'm going to multiply 25. Yeah, I forgot the 2. Thank you. I saw curious looks and I was like, oh, what'd I do? All right. Thank you. 5a times 2 is 10a. Thank you. And then we can distribute the 2 as well. 2 times 5a is another positive 10a. And 2 times 2 is positive 4. And now, again, we can combine like terms. So you've done this before, right? There we have 10a and 10a is 20a's. So 25a squared plus 20a plus 4. Any questions on those 2? It's pretty easy, right? Very good, very good. And then one more. 5a squared plus x cubed. I'm sorry, plus 3x minus 1. I don't know what I was saying there. What operation are we doing here? Multiplication. This is super big. Trinomial times trinomial. And you could do distribution, but it just gets messy. And you can lose things. You can try it. But I actually prefer the box. So we're going to do the box for our notes. And anytime you're going to multiply, the box works great. I'm going to go ahead and just write my terms. 5x squared plus 3x and a minus 1 along the top. And then 2x squared minus 3x and a minus 5 along the side. Because when you multiply, multiplication is actually just finding area. So that's what we're doing. We're finding the area when we multiply 2 things together. And so we really just need to fill in all the little areas. So to do that, fill in this first box. It comes from our leading terms here. 5x squared times 2x squared is what? 10x to what power? 4th. Very good. We are going to multiply the numbers together, but the exponents we add. Same base, add the exponents. This is where our exponents change. 3x to the first times 2x squared gives you 6x to the third. 3 times 2 is 6. X to the first times x squared is x to the third. Negative 1 times 2x squared. Negative 2x squared. Very good. I really like the box method just because it keeps everything really organized. And there's built-in checks. Like our president's supposed to have, but sorry, I digress. No, it's not. 5x squared times negative 3x to the first is what? Negative 15, x cubed. Very good. 3x times negative 3x is? Negative 9x squared. Very good. And then negative 1 times negative 3x? Positive 3x. 5x squared times negative 5 is negative 25x squared. 3x times negative 5, negative 15x. And then negative 1 times negative 5 is positive 5. The reason I like this so much, again, as I said, it keeps things nice and organized, and I love that. But really, your diagonals are going to have all the like terms. And if they don't, then you probably made a mistake. And it's a great way to double check yourself. And so we have a like term, 10x to the fourth. Oh, 10x to the fourth. We have negative 15x cubed plus 6x cubed, which is negative 15x cubed and positive 6x cubed. 9x cubed. Yeah, negative 9x cubed. We have negative 25x squared, negative 9x squared, and a negative 2x squared, which is going to give us negative 36x squared. We have negative 15x and a positive 3x, which is negative 12x. And then the very last one, the constant plus 5 is all by itself. And so it's a great method. It's really, really my favorite one. You can divide this way too, but we won't do that in this test. Do you guys have any questions for me? You will have no problem finishing this worksheet before you leave, so please get